sodium are one of the group 1 metals. It's highly reactive, and in fact, the second on the electrochemical series. This tells us how reactive this is. It is stored in oil as seen to prevent it from reacting with oxygen and water vapor in air. When freshly cut with a knife, it has a light gray, silvery surface which quickly tarnishes and becomes dull. But a very interesting thing is its reaction with water, and I'm just going to get a glass of beaker and add a piece of sodium in it, and let's just see the reaction. So these are already finished, but I'm just gonna add another piece of sodium into it, and that's the solution we have before, that which is more concentrated than when we started. And this reaction should be reactive. Wow, interesting. Let's play it.
Fireworks. Yeah, we all know fireworks. But do you know that this spectacular display of fireworks you see is a product of electrons changing energy levels in different metals of this compound present in the fireworks? So what do I mean? Yellow firework is as a result of sodium, which one of the constituents that's present. Yeah, the same sodium, same as table salt. It makes this sodium electroexcited and makes it move from a low energy state to a high energy state. And then this falls back. In the process of falling back, it releases a photon, which is a packet of light, and that's what gets this yellow color in your yellow fireworks.
This is magnesium, one of the group 2 metals and also one of the lightest metals we have. Its reaction with steam is quite fascinating. That's steam of fire, and I want to try it out. So I caught a piece of magnesium and a steam, that's magnesium burner, and I just, after waiting for a while, I got this very blinding white light. You know, magnesium is very hard to put out once it starts burning and could be explosive if water is added to it. Yeah, so this magnesium oxide produced is practically insoluble in water, as we can see. This is a Vernier Caliper. It's used to measure smaller lengths that cannot be measured with a meter rule, and it has 2 scales, the main scale and the Vernier scale. The Vernier scale is a small scale which is added to the main scale to get the fraction of the smallest division. So smaller lengths such as the diameter of a rod could be measured with a Vernier Caliper as seen. And this is a digital Vernier Caliper, so it reads the results automatically. It could also be used to measure the depth of a cavity or the thickness of a plate, as seen that was used to measure. Then it can also be used to measure the internal diameter of a tube. Thank you for watching. See you in my next video. This is a micrometer screw gauge. For certain measurements, such as the diameter of a wire, the diameter of a small ball, or the thickness of a paper, greater accuracy is required. So the instrument more accurate than the Vernier Caliper is required. In this case, a micrometer screw gauge is used. That is the anvil. Then we have the spin wheel, and then the U shape is called the frame or U frame, whatever. Then we also have the main scale, and then we have the Vernier scale. Then we have the thimble, and that part where it's stored is the ratchet. So to measure the diameter of a substance with a micrometer screw gauge, here we're gonna measure the diameter of an ink pen, and we're just gonna insert it by turning the ratchet so the pen could fit in it, and then we take the readings from the main scale and the Vernier scale. Thank you for watching, and see you in my next video. Bye. Experiment to get your plates, then get your candle, and then you get your water, which already added an indicator to make it visible. And I'm just gonna add this metal object, not compulsory, but I just want to add it there to show you the progress of how the water level decreases. Then just gonna light up my candle. We're just gonna bring our glass jar and cover this up. So let's just watch what happens after we cover this. It's rising because the oxygen is depleted and the volume of air is decreased. That's why the water rises, and that's why the candle also goes out. In simple terms, this is air pressure. The other part, which is the chemical reaction, is the burning produces water and carbon dioxide. Because twice as much oxygen is burned than carbon dioxide released, the air volume decreases.
There are three classes of mammals. The first one, which is the monotremes, simply means egg-laying mammals. These are mammals that lay eggs but feed their young ones on milk. They also have spore, which is a characteristic feature of mammals. The only animals that belong to this group is the platypus and the echidnas. The second is the marsupials. And marsupials are mammals in which the female has a pouch where it rears the young birds which are born immature through early infancy. Some examples of marsupials are the kangaroos and the koalas. The final one is the placenta mammals, and the placenta mammals are mammals which are characterized by the presence of a placenta which facilitates the exchange of nutrients and waste between the blood of the mother and the fetus. All mammals belong to this group except the monotremes and the marsupials. Thank you for watching. We'll see you in my next video. Why are humans able to float on the dead sea? They're able to float on the dead sea due to density. So when an object that has an higher density than that of the liquid, it sinks. Otherwise, it floats. That's why in the case of when an iron nail is dropped over water, it sinks because the density of the nail is higher than that of the water. Whereas when a ship moves on water, it doesn't sink because the average density of the ship is less than water. So humans are able to float on the dead sea because our density is less than that of the dead sea due to the salt accumulation that has made the density of this dead sea to be so great and greater than that of the density of humans. Do you know that the smallest particle to ever exist is not the atom? Let's just do a quick flashback. In 1808, John Dalton proposed the theory that atom is indivisible. He considered atom to be the smallest part of the matter which can be further divided. Discovered that atom actually consists of three different constituents or can be broken into three different parts, and that's the protons, electrons, and neutrons. But wait a second, that doesn't mean that is the smallest particle. The smallest particle is not the protons, electrons, and the neutrons. The smallest particle to ever exist right now is the quarks. These quarks combine together the strong force to form hadrons such as protons and neutrons. Thank you for watching. See you in my next video. Bye.